Next question we are talking about. The diagram shows a sketch of the graph of y is equals to x squared plus bx plus c. The graph passes through a point 1, 2 and minus 3, 6. And use this information to write down the two equations in B and C. So whenever I say a point, so for part A, so we have the quadratic equation to be y is equals to x squared plus bx plus c. So when they give us the first point, which is 1, 2, so this means when the x coordinate is 1, y coordinate is 2. So I can substitute 2 in place of y and 1 in place of x. So that's going to give us b times 1 plus c. So when this 1 square is 1, when it comes to the left-hand side, it's 2 minus 1, which is just 1. 1 is equals to b plus c. So this would be the first equation. And in order to get the second equation, we can substitute the second point. The second point here is minus 3, minus 6. So this means when x is minus 3, y is minus 6. So if I substitute it, so that's going to be minus 6 is equals to minus 3 squared. So wherever we have x, we need to put minus 3. So b times minus 3 plus c. So this is going to be minus 6 is equals to minus 3 squared is 9. And b times minus 3 will be minus 3b plus c. And when 9 goes to the other side, it's minus 6 minus 9, which is minus 15, is equals to minus 3b plus c. Or we can either say it like this, or we can multiply throughout with negative. That will give us 15 is equals to positive 3b minus c. So these are the two equations which we get it for this part A. And this is the right answer for part A. And next, for part B, use these equations to show that this is the equation, the quadratic one. So the quadratic equation was y is equals to x squared plus bx plus c. And right now we got two different equations. One is 1 is equals to b plus c. And the second one is 15 is equals to 3b minus c. So I'm going to solve it by the elimination method. I'm just going to add them. So 1 plus 15 is equals to 16. And b plus 3b has to be 4b. And plus c minus c will get cancelled out. And your 4b is equals to 16. So that gives us the value of b to be 16 over 4, which is just 4. So the value of b is 4. So now we can substitute it in any one of the equation to get the value of c. I'm going to put it in the first one. So it's going to be 1 is equals to 4 plus c. And when 4 goes to the other side, it's 1 minus 4. So that gives us the value of c to be minus 3. And when I substitute this one in this generalized equation, so I'll be getting y to be equals to x squared plus 4x minus 3. And this is the right answer for part B. And next, if I talk about part C, for C part 1, solve the equation x squared plus 4x minus 3 equals to 0 and give your answer corrected to 2 decimal places. So that's basically x squared plus 4x minus 3 equals to 0. As it's just a 2 marker. Okay, so whenever they talk about correct it to a 2 decimal places or something, so you don't have to waste your time in checking whether if there are any factors or not. Or is it possible to split the middle term or not? So we have to think about using the quadratic formula directly. So whenever we have it something like ax squared plus bx plus c equals to 0, the quadratic formula would go something like x is equals to minus b plus or minus square root of b square minus 4ac divided by 2a. And if I substitute all these informations, I'll be getting x is equals to minus 4 plus or minus square root of 4 square minus 4 into 1 into minus 3. And entire thing divided by 2 times a is 1. So which is going to be minus 4 plus or minus square root of 4 square is 16. And minus 4 into minus 3 has to be positive 12. And this entire thing divided by 2. So the two possible answers would be, one would be with minus and one more would be with plus. And that we can directly substitute it in the calculator and check it. So on the calculator, so we will be having minus 4 plus square root of 16 plus 12 has to be just 28 divided by 2. And in decimals, we will be getting 0.645. And for 2 decimal places, this has to be clearly, I have to round up this 4. And because the next digit is 5, so I need to round this one up. So that has to be one possible solution, should be 0.65. And for the second solution, I have to type this expression with negative. So I'll just change it here. So that's basically negative 4.645 for 2 decimal places. It has to be negative 4.65. So these are the two possible answers for x. And for part 2, we are talking about write down the equation of line of symmetry of this graph y is equals to x squared plus 4x minus 3. Either we should be knowing the direct equation, which is x is equals to minus b by 2a. This is the one way of solving it. And in place of b, we have 4, and in place of a, we have 1. So that's going to be minus 4 divided by 2 times 1, which is just going to be x is equals to minus 2. And this would be the equation of line of symmetry. So this is the one way of doing it. Or the second way is whenever we know the x-intercept. So right now we know the x-intercept. So this is 0.65 and this is negative 4.65. So clearly the line of symmetry would pass exactly at the middle. So that has to be the midpoint between these two x-intercepts. So we can also do it like that. So even in that case, we will still get minus 2 as the answer. And this is the right answer for C part 2. And for part 3, find the minimum value of y. So now, in order to find the minimum value of y, so that's basically the vertex. So this one, this particular point. Since we have this line of symmetry, so we clearly know that the minimum value will exist when the x coordinate is minus 2. So which means for the minimum values, all we need to do is, for part 3, we just need to put x coordinate to be minus 2. And whatever the y coordinate we'll be getting it, that will be a vertex. And that would be the minimum value as well. So y would be equals to, if I put it in this equation, so it's going to be minus 2 whole square plus 4 times minus 2 minus 3. And when we simplify this, we will be getting the answer to be, this is positive 4 minus 8 minus 3 would be minus 7. So this would be the minimum value of y. And this is the right answer for the sum.